Let us look at how CRAGER can be used to carry out various case studies. I will discuss two case studies. First is a case study with the fixed stage length, and in this particular study we assume that there are 4 aircraft with 15, 20, 30 and 60 seats. They are operating at a very small stage length of 100 nautical miles, and they are catered to operate 18,000 annual one-way trips. These are assumptions. If this is the market, we would like to establish the sensitivity of the generalized cost of air travel for this market to the changes in the aircraft capacity and changes in the annual travel demand. Okay. So, there are 4 capacities, the stage length is fixed and there is an assumed annual one-way trip, but we will look at how if the capacity is changing, how does for 18,000, how does the generalized cost vary, and then we will vary the demand also and see what happens. There are some assumptions in this study. First assumption is that the cost of the airport development is only at one airport. The base airport is already available and operational. We are operating only daytime flights under VFR, so this will be only level 1 or level 2 airport, it will not have level 3. The value of time is considered to be 85% of the gross annual income. The passenger load factor will be 85% and the constant excess cost of 100 rupees is assumed. Now, you can see, if you look at an aircraft with 15 seats, which you can see in this particular figure, you have a 15-seater aircraft. Now, what do you see? As the annual passenger load, now 18,000 is the average passenger load or the basic passenger load. On this side we are making it half and 1/4, and on this side we are making it double and more than that or double of that. Okay. So, what do we notice? We notice that for a small aircraft which is 15 seats, major cost of travel is the flight cost, and it remains the same, because whether you operate 4,500 passengers a year or 54,000 passengers a year, as long as the aircraft is 15-seater with 85% load factor, its flight cost is going to remain the same. So, that is why there is a fixed number for flight cost. But notice that the time cost is reducing. Okay, I would say that the time cost is very high for a small passenger demand. This is because since we have less annual passenger load, we will have lesser frequency, and lesser frequency means there is more deferred time. When there is more deferred time, you are going to delay your journey more. So, that cost is adding up. But you can see that the time cost is a small component. Similarly, airport cost. Now, when the airport cost is fixed, the airport required to operate this particular aircraft is fixed, okay. But when you are dividing that cost with less number of people, the per person cost goes up, and that reduces and becomes a small number when the number of people who use the airport becomes large. Excess cost is a constant which is given here just for reference. You can notice the blue bar is same in all the 4, it represents 100 rupees. So, what do we conclude is, we conclude that the generalized cost of travel reduces as the number of passengers using the service reduce. They are very high for very small passenger demand, and they reduce. They are the lowest for large passenger demand, but this is for the aircraft with 15 seats. Let us now move to the aircraft with the largest number of seats, which is the aircraft with 60-seater. Here we see that if you are flying an aircraft with 60 seats for this market, which has only 4,500 passengers per year, there is a huge amount of cost incurred in the flight cost, in the airport cost, Here the flight cost is going to be a smaller proportion of the total cost. The airport costs are the ones that are driving the generalized cost of travel. So, the generalized cost of travel reduces very sharply, much more than what happened in this case, but it is driven mainly by the airport costs, because a larger aircraft is going to require more expenditure on the airport. If you look at the 20-seater aircraft, it is almost similar to 15-seater aircraft, the main component being the flight cost, and then the airport costs are becoming prominent, time cost also increases. So, in this case you can see that the airport costs are becoming more than the flight costs for lower passenger load factors. They are comparable for average loads. Okay. And so, what we see is, we see that there is a general reduction. It is not a very sharp reduction here, it is a very sharp reduction here. So, for the larger aircraft, the generalized cost is dominated by the airport cost and time cost. For the smaller aircraft, the generalized cost is dominated by the flight cost, which is the highest component. Now, suppose we vary the annual passenger load and we keep the aircraft capacity also varying. So, what you see here is very interesting. Let us look at first low passenger load. Let us look at low passenger load here. What you see is, for the smallest aircraft, you have high cost, generalized cost. It reduces when you make the aircraft larger, but it starts increasing again for bigger aircraft. So, the optimum value or the lowest value is for the 20-seater aircraft. This is at low load passenger. When you have very high load or when more people are traveling, the generalized cost of travel reduces linearly and the flight cost is the main driver, and all other costs are small in comparison because they are shared by a large number of passengers. So, the time cost also becomes a small component and the airport cost also becomes a small component because more number of people are sharing it. The main cost is the flight cost, and for a small aircraft the flight costs are very high, for a large aircraft the flight costs are very low. So, this is the conclusion. Now, let us look at the second case study. Here we are looking at fixed annual passenger load and we are looking at now the difference because of stage length and because of the aircraft capacity. Now, here I have rationalized the flight capacity to 19-seater, 30-seater, 50 and 70-seater because this is the kind of passenger capacity that you normally see in the aircraft, but I have looked at now constant demand, but I have looked at stage lengths. So, here we want to look at the sensitivity of generalized cost to airport and time cost. We will also look at pressurized and unpressurized aircraft because when you make the aircraft unpressurized, you have severe restrictions on the descent rate. So, we did a comparative analysis of 5 aircraft of 50 seats available. We looked at the block time and the block fuel data and then we did a comparison. So, let us look here first. Now, if you have a small stage length of 100 nautical miles, such as in this particular image, small one, you notice that the generalized cost of travel is almost the same whether you have small aircraft or large aircraft, because in the case of a small aircraft the flight cost is high, right, in the case, but the airport cost is low. In the case of large aircraft, you see that the value of time and the airport cost, that is higher compared to others. So, what you see is almost some kind of an averaging between 30 and 50-seater aircraft. But if you look at now the large stage length, 400 nautical miles, more distance, you notice that the generalized cost of travel falls as the capacity increases and the lowest value is for 70-seater aircraft, and it is dominated mainly by the flight cost. Okay. The time cost and the airport cost are a small proportion, and for 200 nautical miles it is in between. So, here in these two we see a clear cut minimum of about 50-seater capacity, but larger stage lengths means you should fly the largest possible aircraft that can be fitted. Now, this is how we can use this tool for aircraft selection. As I mentioned, we looked at 5 contemporary aircraft with almost 50 seats, and we used the tool for getting the trip DOC with the range, and with that it was concluded that the most appropriate aircraft was the aircraft with 50 seats. So, here is the conclusion of this particular study. On the left hand side, you have the conventional approach to transportation cost estimation in aviation, where we look at the flight cost in rupees per passenger per nautical mile and we vary it with the stage length. So, what we find is that the aircraft with 19 seats has the highest value and that value reduces as the stage length increases. The aircraft with 70 seats has the lowest value of cost per seat per mile and that also reduces with the stage length. So, if you want to reduce the cost of travel, fly longer distances and with large number of passengers. This is absolutely obvious. Look on the right hand side. Here we have looked at now generalized cost of travel. Now we notice here that the aircraft with 15 seats, it does not have the highest generalized cost of travel. That is actually for the aircraft with 70 seats, especially when you are looking at low stage lengths. But when you go to a stage length of 200 nautical miles, there is a crossing over, and when you go to large stage lengths, then you find that the large aircraft becomes better. So, for smaller capacity, the flight cost pushes the cost up. For large capacity, the airport cost pushes up. So, what we find is smaller aircraft have high flight cost, which we know from beginning, but they have low airport and time cost. Larger aircraft have low flight, which you know from the beginning, but they have high airport and time cost. So, the lowest generalized cost is for a 30-seater aircraft for small stages and 50-seater aircraft for 200 and 300 nautical miles, and among the 5 aircraft studied, the best aircraft for the market was ATR 42-300. Thank you so much for your attention.